Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to continue writing equations of lines using both point-slope form and slope-intercept form, but we're going to move away from being given a graph. So we're going to learn how to write equations of lines when we're just given a table of points or just 2 points. So let's jump right in. To start us off, it says some points of a line are given in the table below. First, you're going to graph the line and then answer the questions. So again, these are just some of the points on the line. So when you have those points graphed, you can connect the line and they should all fall in the same one. So take a minute or two, complete the graph as well as answer parts A, B, and C. Okay, so I went ahead and graphed those points and drew the line, and you can see that they all fall in the same line. Part A says, is there a way for us to find the slope? So sure, there are a couple of ways we could find the slope. We could pick 2 points that fall exactly on the corners of these boxes. So for instance, we could use these 2 points, -4, -3, and it looks like 2, 0. It is 2, 0. I just didn't quite put it on 2. And we could look at the change in y over the change in x. So change in y would be +3. Change in x is also positive. That would be +6. So we could do the change in y over the change in x is equal to 3/6, which is equal to 1/2. You might recall from our previous lesson that we don't have to know what the graph looks like to be able to find the slope, right? We can find the slope if we are given 2 points. So we could pick 2 points from this table, and I'll pick 2 different ones just to show you that it's going to be the same slope. Let's do these 2 points right here. If you remember the slope formula we talked about the other day, we had change in y over change in x is equal to y2 minus y1 all over x2 minus x1. Well, here's our x values, right? We'll call that x1, x2, and we have our y values here. We'll do y1, y2. So that gives us 1 minus 0 all over 4 minus 2, which gives us 1/2. So you could use the graph and count the change in y over the change in x, or you could use what I would consider the better way to find slope, because it works every time, right? If we have a graph, it's really only easy to count the change in y and the change in x if the graph is ticked off by individual units, right? Which this one is, so no problem. You could go and count. But the slope formula over here will work regardless of whether you have a graph or whether the graph, is ticked off by 5s or 10s or some other type of number. Okay, is there a way for us to find the y-intercept? Well, by looking at the graph, we may not be exactly sure where that y-intercept is, right? It's somewhere right here, but does it go through exactly -1, or is it a little bit above, a little bit below? Remember, my line that I drew, right, is not perfect. A computer could give us a perfect line, but even then, we may not know the exact location of the y-intercept. If you think back to our previous lesson, if we came up with a point-slope formula of the line, right, or a point-slope form of the equation of the line, we could convert that to slope-intercept. And if we knew what the slope-intercept form was, well, we would know what the y-intercept is. So let's go ahead and do that. I am going to use this point right here. Actually, you know what? It's easier to work with 0. So we'll use this point, 2, 0. So point-slope form, y minus y1 is equal to m times the quantity x minus x1. My y1 is 0, so y minus 0. My slope is 1/2, and my x1 is 2, so x minus 2. If I simplify here, I get y is equal to 1/2 x, let's make sure I put an x there, minus 1. Again, that's after I distribute this 1/2 to both the x and the -2. So this is our slope-intercept form, which means our y-intercept is -1. Part C says, what is the equation of the line above? Write your answer. Write your final answer in slope-intercept form. Well, we just did that. We went from point-slope form to slope-intercept form. The equation that I starred would be our answer for part C. Okay, let's do a few more problems while we talk through some of these things in a bit more detail. So we're given another table, and we are asked to find the equation of the line in slope-intercept form. So take a few minutes, employ the process we did above, right? We won't need to graph this line, but you'll notice that above, we didn't really have to graph it either, right? We had a way to find the slope without counting the change in y and the change in x in the graph. So we could do the same thing here, and they give us plenty of points, so we can pick any of them to use as our x1 and y1. So take a few minutes to work through it and then come back and see how you did. Okay, so remember, we're going to start with point-slope form. So y minus y1 is equal to m times the quantity x minus x1. So we need to find the slope and pick a point. Let's use these first 2 points to find the slope. We'll call this x1, x2, and y1, y2. So our slope is equal to change in y over change in x, which is equal to y2, so 11, minus y1, which is 3, all over x2, 2 minus x1, 0. That gives us 8 over 2, which is equal to 4. Now, regardless of which 2 points you chose, you should still get a slope of 4, right? Because the slope for a line is going to stay the same. I'll just use the x1 and the y1 that I have in my table. So I have y minus 3 is equal to 4 times the quantity x minus 0. Now again, we can't stop here because it says write your final answer in slope-intercept form. So we just need to keep going. We need to distribute and then rearrange our equation to get it in the form y equals mx plus b. Well, fortunately for us, distributing is fairly straightforward. We just get 4x, right? And then 4 times 0 is 0, so we can just leave it. I'm going to add 3 to both sides, and I'm going to get y is equal to 4x plus 3. So our slope is 4, our y-intercept is positive 3. Now again, regardless of which x1 and y1 you chose, right, let me show you how we could do it another way. Let's say I chose my x2 and my y2 to be my x1, my y1. Well, I'd start off with y minus y1 is equal to m times the quantity x minus x1. So I'd get y minus 11 is equal to 4 times the quantity x minus 2. Now when I distribute, I get y minus 11 is equal to 4x minus 8. I'm going to add 11 to both sides. And that's going to give me y is equal to 4x plus 3. So again, whatever point you choose for point-slope form, your slope-intercept form is going to come out to be the same. Okay, so we're not going to do numbers 2 and 3 on the video because they're very similar. You can do those on your own, or we'll most likely do those during class. The one question I did want to talk about is the question below, and it asks us, do we actually have to start with point-slope form here? Or could we have just jumped straight to slope-intercept form, right? Well, let's take a look at the points. If I found my slope, I know my slope is 4. Could I have found my y-intercept just by looking at the table? Take 30 seconds to think, why or why not? Well, if we think about our y-intercept on a graph, here's our line, here's our y-intercept. my x value is always going to be 0, regardless of what my y value is, right? My y value in this case maybe is 2. But my x value we know has to be 0. So if they give you a table of points, and they give you a point where the x value is 0, you can kind of skip straight to the last step, right? Once you find your slope, right, you always have to find that. So slope was equal to 4. But you could bypass the point slope form if you know what your y-intercept is, right? Because you could jump straight to y equals mx plus b. And if you know your slope and you know your y-intercept, again, because that's the point where x is equal to 0, well, you could just jump straight to it. So if they give you the y-intercept in your table, and again, they would have to give you a point where x is equal to 0, you can bypass point slope form. You'll notice that they won't always do that though, right? If we look at number 2, if we come down here, the x values, there is no 0. Right? So we're going to have to go through that process of point slope form and then convert it to slope intercept form. All right. Let's go down to, let's do one of these. So sometimes you'll just be given 2 points, right? And we know that all we need to draw a line is 2 points. We can put 5, 6, 7, 55 points on our line, but all we need to draw a line is 2. So sometimes they'll skip the whole table and they'll just give you 2 points and they'll say, give us the equation of a line that goes through these 2 points. The process is exactly the same. We just don't get the option of choosing between different points, right? They're telling us exactly what 2 points we have to use. So we're going to do number 4. Take a few minutes, find the slope, use point slope form because none of these points are the y-intercept, and then convert it to slope-intercept form at the end. I know it doesn't say you have to convert to slope-intercept form, but we're just going to do it for the video's sake. Okay, so the first thing we're going to do, I'm going to label these points as x1, y1, and x2, y2. So my slope, right, is change in y over change in x, which is y2 minus y1. So I've got 17 minus negative 1 all over 2 minus negative 1. That's going to give me 17 plus 1, which is 18, all over 2 plus 1, which is 3, which is equal to 6. So my slope is equal to 6. Now I'm going to write out the general form of my point slope form. I'm just going to use the x1 and the y1 I already have labeled. So I have y minus negative 1 is equal to 6 times the quantity x minus negative 1. I'm going to simplify before I do any distributing. So I get y plus 1 is equal to 6 times the quantity x plus 1. When I distribute, I get y plus 1 is equal to 6x plus 6. And then if I subtract 1 from both sides, I'm going to get y is equal to 6x plus 5. And if you had used the other point as your x1 and y1, you still would end up with 6x plus 5 for your slope-intercept form. Number 5 is similar, same process, just different points, so we'll cover that one in class. If you want to get a head start, you can, but we're going to end the video here. As always, enjoy the rest of your day, and I will look forward to seeing you next time.